Hello everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics, IARE. The subject we selected for this video lecture is Probability and Statistics. The topic we are going to discuss about test of significance of single mean. Mainly we are going to focus on definition of population and sample. The population and sample relationship also we are going to discuss. The test statistic, what is the formulation of a single mean, that is also we are going to discuss, and based on that we are going to do problems also. Single mean, the standard deviation of population, that is the population parameter regarding sigma, that is standard deviation. If it is given, how to deal. If it is not given, we have to face the problem. Everything we are going to discuss in detail. What is a population? The population, it's nothing but a large collection of individuals or numerical data which is called population. This population may be finite or infinite. A population containing a finite number of individuals or members is called a finite population. That is, the population, what are the data it has, we are able to count, otherwise we can tell small data. A population which contains an infinite number of members, it is called infinite population. It tends to infinity. Mostly here, instead of here, the mathematical, the database is very large data also we can consider as infinite population. Sample. What is sample? Sample, it's nothing but the population data, a small part of that particular population data. That's what here it is written, a part of small section selected from your population called a sample. To understand more clearly, we can, the statistical data of your population, suppose the whole Telangana, what are the engineering colleges, academic status, we want it. Then that is a population, it's nothing but engineering colleges in Telangana. To analyze the population, the parameter what we have taken, that is engineering colleges in Telangana, to analyze, we are going to take a sample, that is Institute of Aeronautical Engineering. So the statistical data of academic performance is very well good in Institute of Aeronautical Engineering. So the sample, based on that, we can analyze what about Telangana academic status. So if it is Telangana is a population, Institute of Aeronautical Engineering is becoming sample for that. So now the sample itself, two types are there. That is a small sample and large sample. That is the sample, how many we are going to take in account. If it is less than 30, we can tell small sample, 30 or above, we will call it as large samples. So now the study about this, that is the process of selecting a sample, is called sampling. The relationship between population and sample, that is the sample which is drawn from that particular population, is called sampling theory. So we are going to what is the population, what is sample, regarding the connectivity between how to calculate the single mean and what is the deal which is given to us, whether to accept or reject. Based on that, we are going to do so many problems in this video lecture. So now here I have just before that one example I have given, that is if it is the population is Telangana, Institute of Aeronautical Engineering is the sample, it is playing a role. Suppose Institute of Aeronautical Engineering, that is we are taking as population, then its 11 branches, they are becoming the samples for Institute of aeronautical engineering. So now, whatever the problem, the conditions, it is given whether to accept or not. A simple way we are writing, that is the student life, the examination, it is our test whether we got that particular subject knowledge or not, for which your fixed data it is there. That is, if it is 40 percentage, yes, we got the knowledge, that is we passed in that particular subject. If it is 60 percentage, that is first class, we defined it. 50 second class, these are all defined, that is parameters. Similarly, now in this population and sample, the connectivity, what is the conditions which are given whether to accept or reject? For that, we want a fixed data. These are all here the slide which shows us critical values of Z. That is 1 percentage, 5 percentage, and 10 percentage. Critical values of two-tailed test. That is, here we are going to use normal curves. The normal curves, the two sides, the rejected area will be, that is, mod Z alpha is nothing but the value 2.58. It is from minus 2.58, that is, this is actually, we can see it, the normal curve. Here we are taking here, this is minus 2.58, here 2.58. So if it is from this two sides, the rejected region will be there for the two tail. Whereas right tail, only right side, the rejected, the shaded region will be. For the left tail test, on the left side, the rejected region, remaining end all accepted region. So for which, so the accepted and rejected region, a point which is making the difference, which is separating the accepted and rejected region. Yes, that point is, if it is two-tailed and the level of significance, if it is 1 percentage, it's nothing but 0.01, that is 2.58. Then if it is 0.05, that is 1.96. If it is, that is in the question itself, it is given what is the level of significance. If it is 0.05 and which tail we have taken, that is if it is two-tailed test, this data to be selected. If it is one-tailed test, in the one tail also, if it is right-tailed, then we have to see 1.645. If it is left tail, it is 10 percentage, that is 0.1, we will be selecting this data. So these data are called as tabulated values at two tail, at right tail, at left tail. This right tail and left tail, both we can call it as one-tailed test also, because this is a symmetrical line which divides this normal curve equally. That is the section. This section has 0.5 area and this section it has 0.5 area. The total probability is always 1 and it is positive also. So if it is right tail, the shaded only on the right side only. If it is left tail, it is on the left side. They are called as one-tail test. These values we have to remember. Yes, this is the first problem. According to the norms established for a mechanical aptitude test, persons who are 18 years old have an average height of 73.2 with a standard deviation of 8.6. If 4 randomly selected persons of that average 76.7 test the hypothesis mu equal to 73.2 against the alternative hypothesis mu greater than 73.2 at 0.01 level of significance. This point now it's very clear. Just now that the previous slide we discussed, that is 1%, because 1 by 100 it's nothing but 0.01, and the symbol is there greater than. It indicates that right-tailed test, that is one-tailed test, for which 0.01, what is the value we have to select. Compulsory, we have to read the question twice, thrice. Now, this is the particular topic we are discussing, that is a test of significance of single mean. So naturally, under which the problems comes under this topic. But whereas coming to the examination point of view, it's overall the complete syllabus curriculum, the problems will be dominating. Then we must be in a position to identify this particular problem comes under which test of significance. That is the main target the students they have to focus. Yes. The first one is, according to the norms established, some mechanical aptitude test is going on. The eligibility to attend to the particular the exam is 18 years. Fine. So many students are writing that particular exam. That data which is not given, we have to read it very carefully. So how many students are writing the particular mechanical aptitude test, that data which is not given, instead of that mean of all the students, how many students, that means number of students divide sum of their what is that divided by number of students, that is the average formula. So the average, it's nothing but mathematically mean 73.2 and standard deviation is 8.6. So the population mean is, the symbol is mu. That data is 73.2. Population standard deviation is 8.6. So about the population parameter, some condition which is given, that is the mean is and standard deviation. So up to this question, the 3 sentences we read, we got some clarity about it. Then to analyze the population about the mean 73.2 and sigma 8.6, it is defined, we have to accept it. So whatever the statement regarding the population which is defined in the problem, we have to accept. That is called null hypothesis. Whether it is correct or not, the parameter about what is the statement which is defined about the population, whether it is correct or not, we have to check. For which we are taken 4 samples, only 4. That 4 samples mean we are finding, because here it is written averaged. That means only the 4 samples, that is called sample mean, that is 76.7. This is overall complete. All the students they wrote it exam, that mean is population mean, that is 73.2. Only we selected 4. That 4 students mean is 76.7, that is sample mean. Null hypothesis. Here the concept, actually every problem 5 steps are there. The first step is null hypothesis. What is null hypothesis? That is also we are going to discuss. It's nothing but whatever the statement which is defined in the problem, we have to accept it. There is no question about it. Yes, we have to. Here there is no question about it, this data which is given. Now we are ready to accept it. That is called null hypothesis. But mathematically, the second step is we have to reject. We have to reject. So if I'm telling anything, these products are very good. Yeah, it is a statement defined. How to reject? No, they are not good, we will tell. But mathematically to reject, three ways are there. That is less than, greater than, not equal. So the symbol less than, greater than, not equal. Here in this particular problem, it is given to us how to reject. That is, what is the population mean which is given, the 73.2? It's not correct. There is a possibility more also it will be. That's what here 76.7 is there. So the rejecting right-tailed test is there. Why we have to tell right-tail? Because of this symbol right-tailed test. If it is less than, we will tell left-tailed test. Yes. Now we will enter how to solve the problem. Here the presentation is very, very important while answering. N equal to sample size is 4. Mu equal to population mean. This is a symbol for the population mean, that is 73.2. Next one is X bar. Sample mean equal to 76.7. Why here sample mean? Here 4 selected sample, their average is here. That means their particular mean is 76.7. Next, sigma. If it is only sigma, standard deviation. Sigma square, that is square of standard deviation, is nothing but variance of population. Here they made our here 8.6, that is sigma. Standard deviation of population is 8.6. So completely all the data we covered it. Only this is left over, and yeah, we covered all the data. Only 0.01 that we will be covering, and this symbol also we have to cover. This is not a data. Just it is not related to solving. We are not going to use this 18 years and that is just that eligibility of writing that particular exam 18 years. Remaining all the numerical data, we put it in order. Yes, the first point, null hypothesis. H0 is the symbol. This is the statement we have to define about null hypothesis. That is H0 colon mu equal to 73.2. There is no question about it. What is the problem which is defined? We accept it. The second is alternative hypothesis. That is about the population which is defined in the null hypothesis. We are not in a position to accept it. That is only our next step, alternative hypothesis, for which the symbol is H1. How to reject? 3 ways: not equal, less than, greater than. That is, maybe that samples mean, that is samples what we are taking, they can give the report. We are analyzing. Actually, this is the concept of this test of significance of single mean. Population, the data is very vast. So again, once again, to check, instead of that, from that particular population, few samples we are taking and we are checking what is the report. From the samples we are getting, we can tell the population also about what is the report already. It has with us, we can accept it. Now, The data for us in this particular problem, 73.2. We are not in a position to accept that. We decided to reject. So to reject, it is our freedom. That is, but if in the question, if it is clearly given, decrease or increase or more than, less than, taller than, bigger than, like that, if it is given, then strictly we have to use less than or, right tail or left tail. Just a statement which is given. There is any difference? No, there is no difference. Only like that statements if you are giving, we can go for two-tailed test. So we had a general discussion about the overall. Now we will come back to our problem. In our problem, how we rejected, they told us strictly in the problem which is given, you have to reject in such a way. This way only we have to reject. There is no option for us. We have to select compulsory right-tailed test. Suppose in case, if it is here less than, always the best thing to learn, that is we can make more number of problems and we have to do the comparison study between the problems. That is, alternative hypothesis, three possibilities are there: less than, greater than, not equal. In the question it is given greater than, but if I apply there less than, what is the effect will be? Is there any impact more it will be? If it is there not equal, what will happen? Lots of questions. It should ring in our mind. Then only the complete concept which will come into our hands. Yes. Now, level of significance, alpha equal to 0.01. This data also which is given in our question. Yes, fine. Now, alpha equal to 0.01. It is right-tailed test. Here the test is there. And 0.01, that means here the 1%. So this data to be selected. 2.33 is the tabulated data for our level of significance 0.01. So we wrote it. So this is also from the table we obtained 2.33. Yes, fine. The test statistic is, here we can z equal to x bar minus mu by sigma by root n. X bar, it's a sample mean notation. Mu, population mean notation. Sigma, population standard deviation. Small n, sample size. This is the test statistic to calculate single mean. All the data are available. So the particular respective places, the data are replaced. That is x bar as 76.7, mu as 73.2, sigma as 8.6, n as 4. So just to the calculation part, we have done it. The numerator, we obtained 3.5, the denominator 4.3, the final result 0.814. This 2.33, how we obtained, that is from the table just now, 1 minute earlier we discussed it, the tabulated value. So 2.33. And then what about this name? Some name we have to give. This is calculated value. So always the defined, the tabulated value should be higher level. Then this null hypothesis we can accept. This point to be noted very carefully. We have to pay attention more towards that. If the tabulated value is more, the null hypothesis is accepted. Suppose the tabulated value is less than this calculated value, the null hypothesis, that is about the population, the statement what is defined, it is rejected. So on that basis, so now we are able to understand how much the value, these tabulated values are playing a role. Yes. Now we obtained that is a tabulated value 2.33. Calculated value is 0.814. Tabulated value is more, so more than our calculated value. That is 2.33 is greater than 0.814. So the null hypothesis about our mean value which is given 73.2, we have to accept it. There is no question about it. So up to here the problem, but the graphical representation also we can see it. Normal curve. This is the bell-shaped curve, the line which it is divides the curve equally. This is at the point that is mean is z equal to 0. So here we can see it, that is the tabulated value. This point is right tail. That's what this line, the critical region, we can see it. This is a one side only shaded will be there because of, we can see the main fair diagram. Yes. We can very clearly, we can see it in the graph. Why this we selected? Because of the right-tailed we selected. That right-tailed also, why it is selected? We didn't select in this particular problem. They made our job very easy. The question itself, it is very clearly mu greater than 73.2. 73.2 is a population mean. Yes. Now, we can see it here. So we rejected. Null hypothesis is defined. We have to accept it. The population mean is 73.2. Yes, we have to accept it. Why we accept it? Our tabulated value is greater than the calculated value. So the deal is accepted. So we can see it now. Yes, this is the question we are dealing now. So they told her to reject in such a way. Don't accept what is the population mean is defined 73 to point. Don't accept null hypothesis. No, don't accept. The don't accept in three ways. In the problem they told one of the way greater than. Yes. Yes. Here we can see it. So this is the region that is rejected region shaded one. The left part, the complete of section plus the leftover of this section. The arrow marker denotes accepted region. Because this is the tabulated value 2.33. So we can see it 0.8 falls here. Some places here it is there. So that is the region. So it is accepted. So we can accept the population mean as mu equal to 73.2. This complete study, the sampling theory. Yeah, the second problem. A sample of now, the single mean test statistic, it's very clear because we discussed the first problem in very detail. X bar minus mu by sigma by root n. So we need x bar, mu, sigma and n. These four symbols, the data we have to try to pick up quickly reading the question. That is a first target to us. So a sample of 400 items is taken from your population whose standard deviation is 10. The mean of the sample is 40. Test whether the sample has come from your population with mean 38. Also, calculate a 95% confidence interval of the population. Fine. So now, n equal to sample size. Yes. 400 samples we are picking. Yes, fine. From your population, whose standard deviation? So here sigma, which is given 10. Here next, the mean of the sample is 40. So sample mean, that is x bar, is 40. So we got it, n sigma x bar, leftover is mu. Yeah, fine. Here the population with the mean is 38. All the four, the symbols x bar, mu, sigma and n, the particular the values we obtained from the reading our question, we obtained it. First we will focus that. The next, here itself, in this particular problem, also calculate 95% confidence interval for the population. So we can say it n equal to sample size equal to 400, mu equal to population mean equal to 38, x bar equal to sample mean equal to 40, and sigma equal to standard deviation of population is 10. So all the, we put it in order, we wrote it in the solution. Null hypothesis. Null hypothesis, always we will write about the statement which is defined in our given problem. So h naught is colon mu equal to 38. Now we have to reject. That is only our second step. How to reject? They didn't mention decrease or increase anything. Just they are coming from the population or not. So we can tell yes or no. So we have selected here two-tailed test. That is, they are not. That is the population mean which is not equal to 38. We are going to tell. Alpha equal to 0.05. If it is not given, default we are taking alpha equal to 0.05. Now two-tailed, that is 0.05, that is 5%. We need the value. Yes. 5%, that is 0.05. Here two-tailed test, this is the value. That is 1.96. So these values are playing a very, because they are the judgment. God is depends upon this tabulated value. If it is more than our calculated value, then we can accept the defined statement on, that is the population mean which is equal to 38. If it is tabulated value is less, then this is wrong. Then we have to reject. So the level of significance at alpha equal to 0.05 is 1.96. So the test statistic is, it's very clear, z equal to x bar minus mu by sigma by root n. These are the respective places. We substituted x bar as 40, mu as 38, sigma as 10, and n as 400. So simplified, we obtained 4. So here one more thing actually we have to tell. We are getting the positive value, so it is not affecting the problem. If we get that is a negative, compulsory we have to take only modulus of that tablet. Here also modulus of tabulated value. Here also modulus of calculated value. Both we have to take modulus of absolute value only will be taken. So the tabulated value of z at 0.05, level of significance is 1.96. So the calculated value just now we obtained 4. Tabulated value is greater than, sorry actually to say, here we have to see it. Here the symbol is wrong because here the tabulated value is 1.96, but the calculated value is 4. Here it should come less than. here it is put it correctly. So 1.96 less than 4. So the null hypothesis, what we defined the null hypothesis, mu equal to 38. No, sorry, we have to say it is rejected because the tabulated value is less than calculated value. So we can see that this is the basic, the normal curve, and here two sides we have to do the shading part. Our tabulated value is 1.96. That is here minus 1.96 to 1.96. This area is accepted. This all it is rejected areas. This is a graphical representation of two-tailed. So we can see it very clearly here. This is the which is the accepted region and rejected regions. We can see it very clearly. Now, how are the point? Here's the tabulated point is minus 1.962 here plus 1.96. We obtained is here the calculated value is 4. This is just 1 point. We can notice it. The critical value of Z, maximum it is 2.58 is there. So the calculated value more than 3, the null hypothesis is rejected. So easily we can tell off instead of doing all these steps. So mu not equal to 38. It's a two-tailed test. So what we obtained, we defined the null hypothesis is rejected. So next, the same problem, confidence interval formula at 95%. So what is the formula? That is x bar minus, here that 1.96 is there. That is a tabulated value. Is there anything, all the problems 1.96 will dominate? No. This is particular 95%. It is a two-tailed satisfying the critical value of Z, that it is placed here 1.96. Suppose here if it is 99%, regarding that tabulated value will be dominating in this particular places. So easily we can remember the formula in such a way that x bar minus tabulated value into sigma by root n, comma, x bar plus 1.96 into sigma by root n. All the values which are available, so the particular places we replaced it, that is x bar 40. This is the tabulated value, and sigma as 10 and n as, that is 400. So we placed it. The simplifications we have done it. So final, the result we obtained 39.02, 40.98. So this is the way we can calculate confidence interval, the formula at 95%. So we will move to the next problem. It is claimed that a random sample of 49 tires has a mean life of 15,200 kilometers. This sample was drawn from a population whose mean is 15,150 kilometers and a standard deviation of 1,200 kilometers. Test the significance at 0.05 level. Now we have to now, we are very familiar with the formula x bar minus mu by sigma by root n. Yes, we will try to pick the data to satisfy, to replace the particular symbols in terms of these real number data. So now here we are selecting 49 samples. Yes, fine. This is a sample mean, sample of sample mean. So that is sample mean. Here population whose mean, here mu is 15,150 and sigma is 1200. So we are going to write, so n equal to sample size equal to 49 and mu equal to population mean equal to 15,150 the next one, x bar equal to sample mean equal to 15,200. Sigma equal to standard deviation of population is 1,200. So the first point, that is a null hypothesis, H0 is a symbol, mu equal to 15,150. The problem, what is defined about the population condition, we have to accept it. That is our null hypothesis. We accepted and we wrote about the first step also. Fine, the job of the first step is completed. But the step is alternative hypothesis. That is a symbol which is playing H1. How to reject? In the question same, they didn't give any decrease or increase or any condition which is not at all given. Just they told are they coming from that population or not. So the population mean 15,150. Here null hypothesis we accepted. There is no other way for us. Null hypothesis we have to accept it. Then alternative hypothesis we have to reject. We rejected in such a way taking as two-tailed test. So alpha equal to 0.05. Now we know it. Just two problems we have seen the critical value of Z. That is, if it is two-tailed test, the level of significance at alpha 0.05 is 1.96. So the test statistic is Z equal to x bar minus mu by sigma by root n. So the particular places we will x bar replaced as 15,200 and mu as 15,150. Sigma is replaced by 200 and small n is playing the role of 49. So the calculations, the part, the numerator, we obtained 50, and whereas the denominator, which is resulted as 171.43, the final result we got it 0.2917. So the modulus, so anyway we obtained the positive result, it won't, so 0.2917. So now the tabulated value for the two-tailed test at 0.05 is 1.96. Calculated value is 0.2917. So the tabulated value, that is 1.96, which is greater than our calculated value 0.2917. So if the tabulated value is greater, is more, then the deal is accepted. That is what is defined, or null hypothesis is accepted. So this is the basic, actually the normal curve, basic part. The development of this, the next stage of the graph, that is a two-tailed test. So two sides, the rejected part will be there. This part and this part, they are the rejected parts. That is here minus 1.96 to 1.96. This area is accepted. The remaining two tails, they are rejected areas. So here the picture which is given, which is accepted region, and the arrow marks also, they are denoting very clearly which section, which regions are rejected and accepted. Here we have taken, that is the null hypothesis defined as two-tailed. We rejected as not equal, and this is the tabulated value, this is the calculated value. Why it is accepted? Because it is 0.29. Here it comes, here falls here. Minus 1.96 to 1.96. 0.29. The graphical representation also we have to understand. So that is what first the steps already we declared the result. What is the effect will be there in the graphical representation also through this video we are discussing. So 1.96 is greater than 0.2917 and the null hypothesis H0 is accepted. So the next problem, a sample of 64 students have a mean weight of 70 kgs. Can this recorded as a sample from a population with mean weight 56 kgs and standard deviation 25 kgs. So n equal to the sample size equal to 64, mu equal to population mean equal to 56. So we can say take that sample mean equal to 70. So now the 64 students, yes, it's correct. And the particular sample mean 70 are fine. Next, the population mean, yes, this is also. Then 25 kg, yes. All the data we wrote it. The question once again we will read, is there any decrease or increase related any symbols? Nothing, it is there. So we no need to go for right-tailed or left-tailed. That is put together one-tailed test, not required. So sample from the population, yes or no. We can go for two-tailed test. So the first one, how the samples can be regarded as coming from the population. The statement, what is the mean? Mu equal to 56. The symbol is H0. So the null hypothesis, we defined it. So the alternative hypothesis, that is the H1 symbol. Two-tailed test we have taken, mu not equal to 56. How to reject? Samples cannot be recorded as coming from the population. So the level of significance is the third point, alpha equal to 0.05, and the tabulated value is 1.96. The fourth point, so all the problems, 5 points. The fourth point is, the test statistic is x bar minus mu by sigma by root n. Now, in the particular places, we have to substitute the values. Yes, x bar 70, mu 56, sigma 25, small n, the sample size 64. So now the numerator, the value is 14, denominator 3.125. The final result, that is 4.48. The value name is calculated value. So the calculated value is 4.48. The tabulated value is 1.96. So here itself we can tell our tabulated value is not more. The deal should accept, that is, the defined the null hypothesis to be accepted, then this tabulated value should be higher level. But here the problem, it is at lower level, that is 1.96. Our tabulated value is less than our calculated value. So null hypothesis, we are not in a position to accept it. It is rejected. How it is rejected, we can see it. So the mod is that equal to 4.48. So the steps are very, very important. Actually, this problem solving, we should not skip any steps. That tabulated value of z at 0.05, level of significance is 1.96. The calculated value of z is 4.48, and the tabulated value is less than the calculated value, that is 1.96 is less than 4.48. So the null hypothesis is rejected. So the normal curve which is ready to us. Now, then the graphical representation of two-tailed, that is minus z alpha to z alpha. Our minus z alpha is minus 1.96 to 1.96. This area is accepted and these areas are rejected. Our 4 is false here, so it is rejected. So the final result we can see it accepted, and this particular problem, how it is rejected also we can see it. So mu equal to 56 is a defined null hypothesis. But unfortunately, our tabulated value is less than the calculated value. That is what it is rejected. So the question also, here we can see our question. This is the fourth problem we are discussing. Why we selected the reason for this particular problem, two-tailed. So nothing, it is decrease, increase about any information which is not given in the problem. That is, and one more thing, just it is a statement about the samples from the population. We are telling samples are not from the population in such a way to reject mathematically. Two-tailed is the best way. That is what it is selected in the fourth problem, two-tailed test which is adopted. So now we will move to the fifth problem. In a random sample of 60 workers, the average time taken by them to get to work is 33.8 minutes with a standard deviation of 6.1 minutes. Can we reject the null hypothesis mu equal to 32.6 minutes in favor of alternative hypothesis mu greater than 32.6? Yes, in this particular problem, it is given very clear about it, how to reject. Yes, greater than. So we don't have any option to think how to reject it all. Whether, because if it is not given, we have to read the questions twice, thrice, which direction we have to go to reject. But here there is no option is given to us in this particular problem. That is, strictly we have to move towards right-tailed test because of the symbol greater. Yeah, fine. Now, yes, we will move towards the solution. That is n equal to sample size 60. Here it is there. So the next one is mu, the population mean, which is given with a simple notation in this problem. They made our job very easy. X bar, the sample mean. Here the average is there. So 33.8. Sigma, the standard deviation of population 6.1. Here we can see it here. So now we can, this particular problem, there may be a doubt will be there. Here we can see it. Reading the question, in a random sample of 60 workers, you find then means sample 60 we are taking. The average time taken by them to work 33.8, it comes under sample mean, the sentences. With the standard, that means it is not a population mean. Yes? Yeah, that is the reason we have to read it very, very carefully. In this, there is a doubt it is coming here in this particular problem. This is sample mean. The same sentence, it continues. Then how we can say this is population standard deviation? That is, we can tell this is sample standard deviation. But the test statistic is x bar minus mu by sigma by root n. Then sigma, which is not given in this machine. Then why we wrote it here sigma? In this particular such problems, suppose if sigma which is not given, we can take sample standard deviation as sigma. Otherwise, sigma can be replaced the sample standard deviation. Test statistic also we can write S by root n. Nothing wrong in it. Here also we can change as S. Standard deviation of sample also we can write. Concept understanding, anyway we can play a role mathematically. So the null hypothesis H0 colon mu equal to 32.6. So we rejected, we didn't reject the problem, the condition which is given, such a way to reject. So rejected in such a way, that is 32.6, right-tailed test. So the third one is level of significance alpha equal to 0.05. So the critical value, we can see it, it's right-tailed, and this is 0.5. Yes, here is there. So 1.645. So the fourth one is, here we can x bar minus mu by sigma by root n. So here it is, if you want, we can write S also. Otherwise, a small one, the sample population equal, that is sample standard deviation, which is equal to population standard deviation writing also, we can proceed to this problem. So x bar, it is replaced by 33.8, mu as 32.6, divided by 6.1, and the n, which is taken as 60. So the numerator is 1.2 divided by 0.788. The final result we obtained, 1.523. So the tabulated value of z at 0.05 level of significance is 1.645. So the calculated value of z is 1.523. So the tabulated value, that is 1.645, which is greater than the calculated value, that is 1.523. So what we defined, the null hypothesis is accepted. So the curve, normal curve, the bell-shaped curve is which is ready, and here our tabulated value will be placed on the right side only. This is the graph, this is the rejected area. So we can see it very clearly, the graphical, how this representation fits to this particular problem, we can see it. So first we have taken the null hypothesis, that is mu equal to 32.6, and we rejected such a way taking right-tailed, and our tabulated value is greater than the calculated value, and that null hypothesis is accepted. So the reason for taking actually the two here right-tail, this is the greater than symbol purpose, we have taken the right-tailed. So the next problem, an oceanographer wants to check whether the depth of the ocean in a certain region is 57.4 fathoms, as had previously been recorded. There is a big ocean, the depth, so many, the regions, 57.4 fathoms are there. It is a record, some record it is there. Whether it is correct or not, it's not again to check all the records. That's what our sampling theory. We will take some regions. How many regions? Yes, 40 random locations we are selecting, for which the sample mean we got at 59.1. Yes, the level of significance is 0.05. So now that here also sample mean, this is also sample standard deviation. If population standard deviation which is not given, we can take in the place sample standard deviation. If it is the test statistic also, we can change it S by root n, otherwise we can just notation we can write it S equal to sigma. Both are correct. So n equal to sample size 40, mu equal to population mean equal to 57.4. So x bar equal to sample mean equal to 59.1. Sigma, standard deviation of population, is 5.2. So now, null hypothesis, that is H naught colon, what that is the record, the previous record, they are revealing, they are reporting that the population mean equal to 57.4. Whether to accept that recorded report or not, we are rejecting. That is the depth of the ocean of the certain region is not, what is recorded is not correct, we are telling. So rejecting, taking as two-tailed. So the level of significance is 0.05. So now the tabulated value is 1.96. The test statistic is x bar minus mu by sigma by root n. The particular places we have to replace it, the values 59.1 minus 57.4 divided by sigma 5.2 by square root of 40. So we got it 1.7 divided by 0.8. The final result obtained is 2.07. So the modulus of that calculated value is 2.07. So here itself we can notice it, the tabulated value is 1.96, whereas the calculated value is 2.07. Tabulated value is less, the deal is rejected. So we can see it how, that is what the steps which are written here, that is the tabulated value is less than the calculated value, 2.07. The null hypothesis is rejected. That means what we define the collected data of certain regions, the depth of the ocean, what that calculation is rejected. So the normal curve which is ready, now it is, we have taken two-tailed graphical representation, that is from here minus 1.96 to 1.96. The region is accepted. Other two sides here, they are the rejected regions. So this how to fit this graphical representation for this particular problem. So here we can see it from here. This is the area for the accepted region. This arrow marks denotes that, whereas rejected region, because it is a two-tailed test, two sides of the shaded regions are there. Our calculated value falls on the rejected region. That is what we defined on the null hypothesis. H naught is rejected. So next we will move to the next problem. A sample of 900 members has a mean of 3.4 centimeters and standard deviation 2.61 centimeters. Is this sample has been taken from a large population of mean 3.25 centimeters and standard deviation 2.61. If the population is normal and its mean is unknown, and find the 95%, that is the limits they are asking. So we can see it now, n equal to, that is 900 members we are selecting, and mu equal to population mean. Yes, it's very clearly it is given 3.25. Sample mean, the sample is 900, sample mean, that is 3.4. The standard population standard deviation here 2.61. Here one doubt. So here it is given 2.61. In this particular problem, the sample standard deviation also given 2.61. Nothing wrong in it. So sigma by root n we can put, otherwise s by root n. Now that what is the question? The question, it is the samples are coming from the population or not? Yes or no? So we can go for two-tailed test. So we wrote it. What is defined on the null hypothesis about the population? The information H naught colon mu equal to 3.25. So that samples are taken from the large population. How to reject? We selected in this two-tailed test, that is H1 colon mu not equal to 3.25. So the samples which are not taken from the large population, the level of significance alpha equal to 0.05. So the tabulated value is 1.96. We know the test statistic is z equal to x bar minus mu by sigma by root n. In the particular places, the values are replaced. That is numerator 3.4 minus 3.25. That value is 0.15. Whereas the denominator sigma by root n, that is 2.61 divided by square root of 900, that is 0.087. The final output is 1.724. So the modulus of z is 1.724. So here the tabulated value is 1.96, whereas calculated value is 1.724. So the tabulated value is more. So they are coming from the large population, that is the null hypothesis, what is defined, we are ready to accept it. So the tabulated value of Z at 2 tail is 1.96, calculated value is 1.724. So the tabulated value is greater than the calculated value. So 1.96 is greater than 1.724. So the null hypothesis is accepted. So our normal curve, the bell-shaped, the curve which is ready, and the two-tailed, the graphical representation also ready. That is accepted region is minus 1.96 to 1.96. This is the accepted region, and the final output of this problem is accepted regions and rejected regions. How we rejected this particular problem, that is such a way, taking two-tailed test that is not equal 3.25. Why it is rejected? Because of the tabulated the value 1.96, which is greater than 1.724. The selection of this, why it is selected also, in this particular problem, there is no decrease, increase, the symbols are not mentioned. And more the part also it is there, the next part of the same problem, that is confidence interval at 95%. This is the formula x bar minus 1.96 sigma by root n, comma, x bar plus 1.96 sigma by root n. This is the tabulated value, it is not any standard. Regarding 95%, the tabulated value which is placed here according to 99% or 90%, what are the percentage which are given according to the tabulated values to be placed in these particular places. Now this regarding this our problem what we are discussing, the data are replaced in the respective places, and final output we obtained 3.2295, 3.5705. So we can see the next problem. An ambulance service claims that it takes on the average less than, yes, in this problem it is given less than 10 minutes to reach its destination in emergency cells. A sample of 36 calls has a mean of 11 minutes and the variance of 16 minutes. Test the climb at 0.05 minute significance. Here in this particular problem, we can't take a two-tailed test because they rejected in such a way that is less than it is there. So we have to strictly move towards that particular left tail. Now n equal to 36 because a sample of 36 it is there. Next, a population mean. So here the average, all the, that is the ambulance service, that is average mean is 10, it is there. This is the sample mean is 11. And here variance of sample, that is a S square. So S equal to standard deviation of sample is 4. So here we have taken the left-tailed test because of the reason the question it is given decrease less than symbol which is denoted there. So the level of significance alpha is 0.05. Here we have to 0.05 and left tail here, that is minus 1.645. So here one more, the doubt because in the we have seen in the table minus 1.645, but here the minus symbol is missing. We will take always tabulated value and calculated value modulus of. Then the next question it is there focusing as, then why the minus sign? What purpose we have to keep the minus sign? The minus sign only for, that is a normal curve, which direction we have to move. The shaded area, which direction, which side of under the normal curve. So now in this particular thing, the shaded part in the left side, that denotes the negative sign, but value will be taking the area always positive, 1.645. This point the students should be very careful in marking the points. So now the test statistic is z equal to x bar minus mu by s by root n, because the particular problem sigma, which is not given. That is, population standard deviation is not given. Instead of sample standard deviation is given. That's what is by root n. So 11 minus 10 by 4 divided by square root of 36, which is equal to 1 by 0.67. The final output we obtained 1.5. So now the tabulated value of z at 0.05 level of significance is 1.645. So the calculated value of z is 1.5. So the tabulated value is greater than calculated value. So we know it if the tabulated value is at higher level, is greater, then the deal what we defined on the null hypothesis to be accepted. Yes, we accepted it. So now our bell-shaped normal curve is ready, and we have to, this is the reason. Here we have seen minus 1.645. Why the vertical line? This is a shaded region. Left side, that purpose only, that minus. But these areas, what all here it is there, all are positive, because probability is always, the value is positive. So the final output of this particular problem, we can see it, accepted regions and rejected regions, we can see it. So now the rejected region, accepted region, and why we selected also, here it is there in this particular problem, we selected the left tail because of the reason less than 10 minutes. Suppose if it is not given this less than, we can take it to tail. If it is more than, we will move to right tail. So here 1 point, the tabulated value 1.645 is greater than our calculated value. So the defined the statement or null hypothesis is accepted. So we will move to the next problem. In 64 randomly selected hours of production, the mean and the standard deviation of the number of accepted pieces produced by an automatic stamping machine or x bar equal to 1.038 and sigma equal to 0.146. At a 0.05 level of significance, does this enable us to reject the null hypothesis? What we defined the null hypothesis, that is mu equal to 1.000 against the alternative hypothesis. Yes, in this particular problem, they told us how to reject. That is, looking at the symbol itself, we can tell easily right-tailed this problem to be focused. All the data are very clearly given. X bar is there, sigma is there, and this is n. 64 randomly selected. Then what is missing? Mu. Yeah, here it is given. Everything which is available. So n equal to sample size equal to 64, mu equal to population mean equal to 1.000, yeah, that is 1. X bar equal to sample mean equal to 1.038, and the standard deviation of population is 0.146. Null hypothesis, we defined h naught colon mu equal to 1.000. The alternative hypothesis, that is a symbol h1 colon mu greater than. In this particular problem, we didn't select. It is strictly, it is given the symbol greater than. So write tilde test. If it is given strictly greater than, if by mistake, if you move towards two-tailed test, it is totally the problem wrong conclusion. So we have to reading the question, we have to be very careful. If it is clearly mentioned, decrease, increase the stages, we have to move selecting those tails only. So now the level of significance alpha equal to 0.05. Yes, greater than right-tailed test. 0.05, the right-tailed test. 1.645, the value which is selected from the critical value of Z. This is the tabulated values. They are the values giving the decision-making values, whether what is defined on the null hypothesis, the deal to be accepted or rejected. So 1.645, the test statistic is Z equal to x bar minus mu by sigma by root n. So the values we substituted in the particular places, the numerator 1.038 minus 1.000, that is, they are replaced in terms of x bar minus mu. The output of numerator is 0.038, whereas coming to the denominator, sigma by root n, that is 0.146 divided by square root of 64. It's nothing but 0.018. The final output is 2.11. So now, here the tabulated the value is 1.645, whereas the calculated value is 2.11. Here itself we can declare the result. The tabulated value is less. To accept the null hypothesis, it should be more. But if it is less, we can tell the deal is rejected. So we can see it, how to write the statements, the presentation of the solution. That is tabulated value of Z at 0.05, level of significance is 1.645. Calculated value of Z is 2.11. Here it should be written 2.11. So the tabulated value is 1.645 is less than 2.11. So the null hypothesis what we defined is rejected. So our bell-shaped the symmetrical line which divides the normal curve, and it is a V right-tailed. That's what this rejected region. It is a right side. The final output of our regarding our given problem representation graphically, that we can see it now. The regions here only, this is the rejected region. Our 2.1 it falls here because our tabulated value is 1.645. If it falls in this area, then it is accepted. This all completely accepted region, that is critical value, this is called 1.645. But ours is 2, it falls here, then it is rejected. So because of this greater than symbol, played your role here to select right tail. Yeah, this is the final problem. Trucking RM suspects the claim that average life of certain tires is at least 28,000 miles. To check the claim, that is, the RM puts 40 of these tires on its trucks and gets a mean lifetime of 27,463 miles. With a standard deviation of 1,348 miles. Can the claim be true? So now that car, the tires, overall the average mean is 28,000. Whether to accept or not, we can see it here, n equal to 40. This is a statement about the population. It is given. The car tires, the life, how much mileage it can, 28,000 mileage it can. Whether it is correct or not, for that we are selecting some 40 tires. Their lifetime is 27,463. So this is the sample size, this is the sample mean. With this, we are going to analyze what is defined on the population of this 28,000 mileage is correct or not. So now the population mean is 28,000 miles, whereas sample mean is 27,483 miles. Here regarding here sample standard deviation is given, population standard deviation which is not given. So reading the question, we have to be very, very, very careful, paying attention. because 40 sample mean. So the same sentence with a standard deviation of sample standard deviation which is given. So that is what here, instead of sigma population standard deviation, sample standard deviation symbol is capital S. That is, the data is 1348. If it is a population standard deviation is given, the notation x bar minus mu by sigma by root n. If it is given sample standard deviation, sigma, which is replaced by capital S. So now the null hypothesis about the population, the statement, that is the tires can be taken as 28,000 miles. So that is mu equal to 28,000 H naught colon. We are rejecting as taking two-tailed test, that is we are not in a position to accept the tires up to 28,000 miles, it is not possible. So the level of significance alpha equal to 0.05. So the two-tailed test at alpha equal to 0.05 is 1.96. The test statistic has z equal to x bar minus mu by s by root n. So now the particular values which are replaced here, 27,463 minus 28,000 divided by 1,348 divides square root of 40. All the values in the test statistic, they are replaced. So finally we obtained minus 537 divided by 213, which is equal to minus 2.52. So here it's very compulsory. That is what, whether it is positive or negative, tabulated value and calculated value, mod of we have to find. So 2.52. So the tabulated value of z at 0.05 level of significance is 1.96. Calculated value of z is 2.52. So the tabulated value which is less than calculated value, that is 1.96, which is less than 2.52. So the null hypothesis, that is rejected. That is what the tires up to 28,000 miles, no, it is not possible. We are not in a position to accept the null hypothesis up to 28,000 miles, it is rejected. So the symmetric bell-shaped curve is ready, and two-tailed test, that is minus z alpha to z alpha, the minus z alpha taking the value minus 1.96 and z alpha is 1.96. This particular section is accepted. These two sections are rejected sections. So in detail, we discussed so many graphical representations, completely nearly more than 10 problems we discussed under this topic, test of significance of single mean. Thank you very much to you all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.